one time we shall give you an opportunity to talk to the department about your innovations. So guys have very interesting innovations. Now we want
Good morning.
Good morning.
My name is Paul. I'm here to introduce to you construction of an automated irrigation control system or scheduling system. And in this project, I'm being supervised by Dr. Nicholas Chiku. Irrigation
sort of S or X?
S.
When did you use X?
What's up?
Irrigation has long been adapted to be used in farms as an additional, or as a mechanism to provide additional water than that one that can be available by the rainfall, because we all know that rainfall can no longer be dependent upon. Now, this has brought in concerns and studies in irrigation, and there's people have scheduled and constructed properly designed irrigation systems that can work and can generate profit for the businessmen. But however, scheduling of these ones on the farms themselves is becoming is a problem. So for people who practice like urban farming from here, who have to pay for the water to use for irrigation, they end up wasting most of the water and they are at a loss of benefiting from their business investments. So when poorly done, over irrigation will cause inhibition of germination, will impede proper root growth, will increase surface soil concentration by osmosis, and it will cause all dangerous things that too much water causes. And on the contrast, too little water also will cause wilting of the crops themselves, and which is also a financial problem. So, my problem description is that for excellent crop water use efficiency were achieved on the farms themselves where these irrigation systems are being planted and where they are being deployed. Because supplying the correct amount, the precise intervals at the correct timing, and the minimum wastages, and depending on the crop stage of that crop is almost impossible to achieve. So, to justify this, people who have carried out research have realized that more than 50, others even in literature say that up to 90% of the water that has been supplied is always wasted. Because when we supply this too much water to the crops, when they are already developing stages, they will not take it up because they will not take up more than what that issue is taking. So the main objective, therefore, of my study is to increase the water use efficiency on this farm. How am I going to do it? Is first of all by designing the irrigation system and testing this system on the farms. The methods that I'm going to undertake to carry out my objectives are, first of all, I will collect data from Bolobi National Agricultural Research Institute and from KAIS. I also have to go collect data about the proper irrigation scheduling, depending on which crop and which growth stages, and also depending on our own climate here. And after that, I will put this into design as my design considerations when I'm writing the code, the program that is going to be executing the irrigation pumps. Then I will, this one will be compiled, of course. Then I will assemble, I put together all the different electronics, the microcontroller that is to interpret the signals, then the moisture sensors, the LEDs, the LCD screens, and all those others. Then I'll install it and I'll have to test it. Then on testing, this is how my schematic is going to be. The soil moisture sensors will be planted into the soil, 2 at least. Then they will collect data about the volumetric amounts of the water that is within the soil, within the root depth of the specific crop. Then they will send these signals to the microcontroller, and I'm choosing to use Arduino because it is easier and it is open source. Then this one processes those signals and it interprets them to relay signals that human beings can understand. On the other hand, with the LCD. So this LCD will be displaying, for example, when the available moisture is 7 millimeters. Then the crop water demand, the crop, for example, is maize, and the growth stage is, for example, germination, and the water demand is, for example, 9 millimeters. When it realizes that there is a need to add to top up that moisture content required for the health of the crop, should have pump to irrigate that field with just the exact volume that those crops will need to keep growing. So the expected delivery was a fully operational microcontroller unit, which I've just shown you, and then I will have to embed it into the circuit. So the operator will no longer need to go and turn on the green and the starter motor of the pumps to irrigate. That one will just be planted in and will just be turned on whenever there is need. And then there will be enhanced communication between the group and the farmer himself, because you did see in this place, the LCD, that such and such a group during such and such a time it requires this amount of water so that it can move on properly. Then I'll have to test and establish that maize, maybe at germination or maize, at flowering, it requires this amount of water in this area, for example. Then my activities, I'm going to have to execute them in this order. I identified this problem, why I came up with the idea in August, just after internship. Then I've been reviewing which I believe I'm going to be carrying out research and collecting all that until the time we hand in the final reports. Then I'm now doing the proposal writing, which I'm going to finish by the end of next week. Then I'll design the circuit itself. And then I'll write the code, I'll assemble the prototype, then I write the report, then I come and demonstrate with the project next May. My expected budget so far from mere calculations from the soil, okay, it's not more than 700,000. Ceremony processor, the microcontroller, the keypad. The keypad is for scrolling up and down. Because it is small, you have to scroll up and see what the other details in the groups. Then I'll need the rectifier, transformer to turn the AC to PC and all that. So I want to welcome you to use information and communication technology to enhance productivity in agriculture. Thank you so much.
Okay, thank you, Soto, for the presentation. We can go on here.
Yes, thank you. How did you say you are going to address the different water needs, different crop stages?
That is, I'm just collecting, gathering the data about different crop stages and how much they need to sustain through that stage. So it's already literature, it was already researched according to this. It's a part of my literature review in my report. It is already established.
Yeah, actually, what my question is how your machines will address that, or you are going to.
No, part of the codes that are inside, that are within this microcontroller, part of the codes are maize. For example, if it is a maize crop, we expect it to run because it has a 555 timer, which is supposed to grow from 0 up to 4 months. So when it is at 1 month, that is part of the things that are being displayed on the screen. It needs this amount of water. Therefore, when you're triggering the pump, you should make sure you time the pump so that it will deliver that amount of water, depending on the crop stage.
Then, would it be better for you to see a particular crop?
Which is why I'm using maize.
Using maize.
I'm trying to study maize mostly.
These indicators in your title. So your system will also address eventual irrigation? Yeah.
Yes, because when the moisture sensors are placed in the soil, they detect how much moisture that moisture would have been from the rain, or it would have been from any other source or morning dew. So as long as the moisture is less than what is required, that's when we talk about.
What of the soil? Particular type of soil, like say sandy soil, clay soil.
The moisture amount that is within the soil, it is dependent on the type of soil, but the level at which the moisture is what the data is detecting only.
Because what I know is that there could be moisture in the soil, but it might not be accessible. I don't know whether that's something you have to think about.
Okay, then you are satisfied. You are aware these systems existed.
I was surprised to find that in India there are some people who are also carrying out the same researches.
Yeah, so it means you should try to bring out the uniqueness, the unique attributes in your system. Either maybe you are looking at reducing maybe the cost or improving on the user friendliness of the system. There should be something unique with you.
Those ones that I try to find that the Indians are using, I was shocked that they do not have a display in it, yet I feel like the user needs to know what is actually
But some of them relay information to your mobile phone, for example. No. What I mean, what is the unique in your innovation here? Because it's not a new thing. Automated irrigation systems have been in place before you were even born. But what is unique with this? I know there's something unique, but bring that out. Huh? Okay, other issues?
Is it working on SC or DC? It is working on SC. That's why I have a transformer in my budget and rectifier.
AC?
Yes, SC. There's
So
several
money
different
back.
ones.
No, because where we normally have irrigation, people don't have AC sources. And sometimes the fields, unless maybe, and you want to avoid the aspect of having long wire, because the fields, or if not, then you should tell us this system is only for this target type of farmers.
I'm targeting the farmers who have farms which are powered by usually different.
So then state that clearly and we know, such that if I am a village farmer somewhere without a power source, I am not catered for by solar power. And we know. Yes. Two more and then we. Yes, sir.
Thank you for the presentation, but this is just technicality of the presentation. Your slide design, if you consider yourself a previous presenter, slide design was wanting.
Have you ever heard of that phrase, slide design?
The way you're presenting your information, words that are scattered.
PowerPoint even has already designed the slides. All you need is to feed in content.
So I'm going to ask you another question. If I think there are models already, especially about maize. Maize is one where we start to grow. There are models considered in consideration, there are models considered in soil management, so if I use the same models and I just punch in some variables like the soil type, particle size, and the prevalence of rainfall for an area, okay, and I calculate the amount of water required, and then all I need is to just set my pipe, and then we put automatic switches, which say in the day the switch themselves on for 30 minutes and every 5-hour period. So in that case, I may not use the sophisticated system like proposed. What do you think?
What I think is that the automated systems have been available for quite a time, but they are not so accessible. Actually, fewer people within that have the farms actually don't know that the system exists. So this is also just acting like an automated switch that is planted. But instead of you having to power the farm, you just have to embed it into the farm and ignore it. Just come and take the readings if you need them.
That is where I'm pointing you to. All I need in your system, if I know the information of the area, I'll make the switches. That's just going to figure the reason for how much water, for how much time, and which chemicals. And I don't need the soil sensor, and I don't need, because the crop is maize. The water demand for maize is known. If there were the models of particle size, soil texture, but I just need off the shelf, just buy automatic switches, which by way of pressing button, you can say switch on after every 3 hours, 20 minutes. And then I connect that to the power circuit for the release of water. And then I'm done. I'll be in Kampala and my maize will receive water whenever I'm ready. So,
But I think the middle is what he's doing is bringing in the aspect of real-time precision irrigation, real-time. This is the current condition in the soil.
this is what I wanted to say.
Now the problem
Do something.
Please, that's why I'm saying try to bring out what is novel in the.
The problem with your system, because now I consider it as a biotechnology with biotechnology.
No, but it is not. It how the concept behind the functioning. For the other system, you already know by the time of planting that this is, I'm going to plant maize and this is the requirement. So whether it rains or it doesn't rain, the thing is programmed to run as per that. But for you, you are basing on the actual conditions at that particular moment.
That's what I wanted to tell you. That
But then this element of DC and pump may not also be compatible with the system you are saying, because like a drip, you pump to a storage, then from a storage you gravitate. So you should make it more versatile.
But at first I'm studying it with the sprinkler.
Sprinkler system. So what more?
I had a quick one. What area are you looking at?
As in which place or what hectare?
You use the phrase as in. We're not going. How big is that area you're talking about?
Right
For
now,
that system, sir.
with the two sensors, I'm targeting 1 hectare. Each sensor at the extreme end. So that you get to cover that.
See, it's what we're talking about, sir. You know the variation, in your area, and how it's going to fit into that system to be sure. That's how it is. These are things you need to consider. I think for your project, really the devil is in the detail. At what depth do you put those sensors? If you're saying 2 sensors, at what depth do you install?
The root zone of maize is usually 5 centimeters or more.
No. Actually, we've been thinking forget about maize. And think of vegetables. Think of vegetables, because the root zone of maize is up to 1.3 meters.
You know the variation of water content with depth in soil. What's in the first 25%? You know that variation where you have water then coming down at the bottom. So that drives what depth you're going to put your sensors and what information to feed back to the system. And then just quickly go to your objectives.
Think about the type of sensors also.
You see the main objective there?
That's not the main objective. You're going to do something with a view of increasing water. That is the ultimate, but not the main objective. I told you be careful. In India, this means so I don't know what you want. No, but sincerely, the objectives are total, they all need overhaul, because to design the irrigation scheduling system, there is nothing about your automated system. I think this guy should concentrate on that system, the automation system. Finally.
And if you take that, then it brings in what I was saying, as whether it's going to do any programming by your.
But when we come here in May, you have to demonstrate this. So how are you going to demonstrate it?
Because are you writing an algorithm for this controller of yours?
That is where I'm feeding you the scientific data as pods.
So you're going to develop an algorithm?
Yes.
So have you already thought about the variables within that algorithm? Can you tell us some of those? Because you know the system is dependent on many factors.
So his proposal should have the flow chart.
What we're talking about, imagine
The algorithm.
several dependent factors that determine when and how.
And that should appear in the literature review.
So now when I start getting those controllers and others, then I'm saying, what will this one have entered into the system for it to behave in a certain way
say this specific variable has gone beyond the limit, you will now trigger the system to work. And then again, at this stage when you come to the proposal is worried about what will happen in May if you come and then what we see is an asset properties that are going to the market. You won't have applied the engineering indications they have the
Take note of that. And on that note, you add me as one of your supervisors because I think you need to supervise your program.
You were talking about the variables that are going to be these moisture sensors, okay, from the electrical side, they have determinants, so they work as the voltage dividers. The resistance of the cell depends on how much moisture is in. So there is a threshold at which they will trigger a bigger pulse that will send, which every pulse they send the microcontroller is interpreted. But there is a point where the voltage has gone to the limit where we said no, the resistance is too little. That means there is almost no after that.
That's what will be the work of if you talk like that, that would be like a project of an electrical engineer. For you are mixing the hardware and the software, and in the middle you are talking irrigation.
Software, hardware to solve it.
Because the hardware is there, you can just buy it and assemble. But you are trying to get hardware with the irrigation principles. So I think the way I look at this, you add me as one of your supervisors. Okay, so I think we conclude with this guy. Lab view?
Yes, whatever you use in optimizing your product. Because I think you need to run out of the model fast before you go out there.
Then they will go for break.
Which software do you think, or do you have already?
Yeah, I use the I program them in the city and I transfer them to a
If you will find out free or not, you don't need to use C and
You have been doing these things. Review, but do a review is a serious future review, covering all the.
then you'll be able to learn a lot of things. And then the software will just be very good to you. Possible that then eventually you are saying, like you say, you can much pay when you come here and you just assemble.
Yes, what is already.
Things are from this market and then put together.
Because when you go to these irrigation dealers, they already have these things functioning, like in landscape irrigation, they already using them here in Kampala. So try to think of what is my contribution, but we will discuss. Can we clap for